Our sample project uses LINQ to SQL to retrieve data from the Northwind products table. Now, I didn't have to do this. I just wanted to have real data to work with and didn't want to hard code it. So although we haven't really delved into LINQ to SQL yet in this course, you'll have to just go with it here and follow along and believe that the data could have come from anywhere. And once we have the LINQ to SQL work done, to load the data up into a collection of objects, the rest of it is just linked to objects. We're going to create an IEnumerable of product class. And all the remaining code we'll look at uses LINQ to objects to query that IEnumerable collection. Let's look at the code that sets this up so we won't have to explain it again as we work through all of our samples in this section. Because we'll be working with products from the products table in Northwind, I'll need a class that represents a product. I have a product class here, which includes the using statement for system.data.link.mapping. And within the class, we've set up attributes that map objects within the class to columns within the database. Here we have a table attribute indicating that this product class maps to the table whose name is products. For each of the properties within this class, we have the column attribute, which indicates that this property maps to a column of the same name within the products table. Finally, I have an override for the toString method, which allows me to easily see the contents of a given product, just to convince myself for debugging that we have the right product in hand. Now, this is using LINQ to SQL techniques to do this mapping. Normally, you would use the object relational mapper. I've set this up very quickly in code without using that mapper to keep things very simple. Now, back in our program class, I have a procedure called getProducts. GetProducts returns an IEnumerable of product, and that's all we need to know. It does its work by creating a new data context given a connection string, and then it retrieves a collection of customer rows by calling the getTable method using product class as the type of each row, and it returns that collection as the return value of the method. We don't need to look at this method again. All we need to know is that it is a method that returns an enumerable collection of product instances. By being an enumerable method of product instances, it's a queryable collection, and we can use LINQ and its various methods on that collection. That's all we need to know for now. We're not focusing on LINQ to SQL. I just wanted a collection of interesting data to work with for these samples. The enumerable class provides several methods that help create sequences. There's enumerable.range, which gives you a range of integers between two endpoints. There's enumerable.repeat, which repeats an item a certain number of times. And enumerable.reverse, which reverses an existing collection and gives you the results of that reversal. The enumerable class also provides methods that allow you to select sequences. There is the select method, which you've already seen, and the select many method, which you haven't. The select method corresponds to the select clause in a LINQ query. The select many method corresponds to multiple from clauses, and it's outside the scope of this section. You'll need to learn about that when you work with real data where you might need to have multiple from clauses. Now, the select clause has multiple overloaded versions. You can project data. We've seen examples of this already. And you can project data along with the index. For example, if you want to know where each item appears in the collection, the select method gives you an overloaded version you can use that gives you that information. What if you want to retrieve a single element from a collection? Perhaps you want to work with an individual customer or find the last product in a sorted list of products. Queries generally return a collection of items, not a single item. Even if there's only one in the collection, it is a collection, not a single item. To retrieve a specific item, you'd have to iterate through that collection. Even if you know there's only one, that seems like extra effort. The answer is to use one of 8 different extension methods. There's first, last, single, or element at. First returns the first item. Last returns the last item. Single returns a single item given a criterion. And element at returns the element at a particular index within the collection. One problem is each of these raises an exception if something goes wrong. For example, if you call the first method but there are no items, or you call the last method and there are no items, you raise an exception. If you call the single method passing a where clause, if the results return no items or multiple items, it raises an exception. If you call element at and pass an index that doesn't exist, you'll raise an exception. To work around that, you can use any of these methods: first or default, last or default, single or default, or element at or default. These won't raise an exception if you pass an invalid criterion or an invalid location. Instead, they just return an empty value, a null value in C# or a nothing value in Visual Basic. The first set retrieves a single element or raises an exception on failure. The second set retrieves a single element or null reference on failure, making it easier to work with the second set, unless your goal is to raise an exception. For example, if you're working with a collection and you know something should be there, so you use the single method to find that one element, perhaps a customer with a particular customer ID. If you don't find that customer, something's terribly wrong. In that case, you might want to call the single method, so you do raise an exception if you can't find that particular row. If you don't know if the customer is there, you might call single or default, so you can then check to see if the result was null, a null reference, and if so, go on about your business. Let's look at examples of these three techniques: retrieving a new sequence, selecting a sequence, or retrieving a single element. I'll start with option G, creating sequences, so we can see how you can use LINQ and its extension functions to create new sequences. Here I'm not using my product data because I'm generating new sequences. The first one is enumerable.range. Enumerable.range allows you to specify a starting point and the number of elements to retrieve. Here you'll see we start with 1 and generate 10 items, and we end up with a collection that looks like this. This is really useful if you ever need a collection of integers from one endpoint and a certain number of them. For example, if you're filling a drop-down list with the numbers from 100 to 200, you could just say listbox.dataSource equals enumerable.range and the range you wanted. Very easy way to do that. Let's say here we want to create a collection with the word appdev repeated 5 times. Simple to do. Enumerable.repeat. If we run that, we end up with the word appdev 5 times in the collection. I'm sure you'll find a use for that. Enumerable.reverse allows us to take an existing collection and retrieve a new collection in reverse order. So if I here take items.reverse, we should generate the original collection in reverse order. Now, why am I focusing on these methods here? Because these are all methods of the enumerable class, which are either called as static methods here or as methods of an existing collection. But in any case, these are methods that extend other things. Reverse is an extension method of that collection class. Let's review how you might select sequences using the select method. In this case, I'll retrieve a queryable list of products. Remember that getProducts method we looked at? It returns all the products. I only want the ones where the category ID is 1. So let me get those first. Okay, well that's one way to get it. We could also use the query syntax, where prod.category equals 1, select prod from our collection. Well, I haven't really used the select method yet, so let's try that. Here, I'm going to use the select method. Now, the select method can either take a single parameter or 2 parameters. Here, the select method is taking 2 parameters, prod and index. If you pass it 2 parameters, the second one ends up containing the index of each item, and the first one contains the item you're selecting. So products.select prod comma index, this lambda expression here is going to give us string.format as the output, 0 dot, and then the first parameter. So we'll get the index, then the product name, and as you'll see, that select method allows us to create a numbered list of products where the category ID is 1. Again, the select method, the normal way, you just pass it a product and then do something with the product. But if you pass it 2 parameters, the second one will contain the index of that product, and you can use that index in any way you like. If we want to now retrieve single elements, I'll press item I. And here we have a number of different things we're going to do. We'll start by using the where clause to just give us 1 product. So remember, query 1 has 1 product in it. Query 2 has all the products in category 5, so it has more than 1 product in it. Now we could have done that using the where method. I just point this out. We could have created a query using the where method and a lambda expression. I'm just showing you can use either query syntax or functional syntax, get the same results. This one says, get me the product where the product ID equals 999. Well, there is no such product. So query 3 will contain no products. Query 1 has 1 in it. Query 2 has a number of products. Query 3 has no products in it. Okay. So now I'm going to call query1.single. That returns a single product back to me. And since query 1 contained a single product, that doesn't raise an exception, and we see the product name displayed. Works fine. Now, let's call products.single, passing in the original products collection. That's all of them. And the single method accepts a lambda expression which defines the where clause you're looking for. So this is like creating a new query. So products.single passing in this lambda expression says, get me the product whose product ID is 1. And as long as this returns exactly 1 result, no damage occurs, no exception is raised, and we get the product name. Great. Let's take query 2, which contained multiple products for category 5, I believe, right? Yep, category 5. We'll ask for the last one. And the last product in category 5, that worked fine, was whatever that is. Now let's try raising exceptions. For example, let's try calling the single method of query 3. Query 3 had no items in it. So the single method will raise an exception because there is no way to retrieve a single item. It fails, and exceptions take a long time to handle. And the result is sequence contains no elements. Okay. Let's try another one that raises an exception. Query 2.element at 200. There aren't 200 elements in category 5, so that fails, of course. We get an exception, and we display the results, which is specified argument was out of range of valid values. Parameter name : index. Okay, that was the message. Now these, because we're calling single or default, won't raise an exception. They just return, well, the default value, which is null. Here, we'll call single or default on query 3, which contained no results. No exception, but is product ID 999 nothing? This is either true or false. Of course, it's true. It is null. Now, let's try another. Because there are at least 2 products in category 5, we know that element at or default will return a valid value from query 2, which had multiple values in it. This should return the one at the second index. Product number 2 is nothing isn't true. That's false. It returned a real value. Product here contains Singapore, whatever that is. But there aren't 200 products. So if I attempt to retrieve the one at position 200, this doesn't raise an exception, but it is null, as you can see. So we found out that we can use either the simple versions of the methods like single, or the more complicated ones like single or default, and get different results depending on the contents of the collection we're trying to query.